All right, today instead of arithmetic, we're going to go over geometric, which is 11.3 in your book. So geometric is multiplying. So you're going to multiply to get to the next number. For instance, 2, 4, 8, 16, right? You're multiplying by 2 each time. And they call that the common ratio. So the common ratio for this would be 2 because we're multiplying by 2 to get to the next term. So the first example says write the first 6 terms of the geometric sequence, with the first term being 12. So you know your first term is 12. And you know your common ratio is a half. So you're going to multiply by a half. So half of 12 is 6. Half of 6 is 3. Half of 3 is 3 over 2, or 1.5. But I don't want to get into decimals. Let's just leave it as a fraction. Half of 3 halves, so 1/2 times 3 halves is 3 over 4. All right, 1/2 times 3 halves. 3 times 1 is 3. 2 times 2 is 4. And then 1/2 times 3/4 will get us 3 over 8. All right, 1/2 times 3/4 gets us 3 over 8. There's your first 6. The general term formula is a sub n equals the first term and then ratio to the n minus 1, the common ratio to the n minus 1. So here we want to find the 7th term, so we want to find a sub 7. They tell us the first term is 5. That's a 5. Times our ratio, which is -3. I'm going to go ahead and put that negative in parentheses. And to the n minus 1, so 7 minus 1. Here we have 5 times -3 to the 6th. And then you type it in your calculator. You got 5 times 729, which is 3,645. You are definitely going to need calculators for this lesson. Next one. Write the general term for the geometric sequence. So we're going to use our formula. A sub n equals a sub 1 times r to the n minus 1. So let's write our general term formula. So a sub n is the first term, which is 3, times our ratio. So we have to actually figure it out here. To get from 3 to 6, I had to multiply by 2. To get from 6 to 12, I had to multiply by 2. You can also find it by dividing. If you do 6 divided by 3, I get 2. 12 divided by 6 gets me 2. 48 divided by 24. So my ratio is 2 to the n minus 1. So there's my general term formula for this geometric sequence. Then we're going to use the formula to find the 8th term. So we want a sub 8, which is 3 times 2 to the 8 minus 1. And we do a little math. And we have 3 times 2 to the 7th, which winds up being 384. So that would be the 8th term. That would be the 8th term in my sequence. Instead of sitting here saying, oh, times 2, times 2, times 2, that gets a little annoying. You can just plug it in. Find the sum. So we also have a sum formula. We can find out what they should all add up to. And again, the pieces are pretty consistent. A sub 1 is still your first term, number of terms in your ratio. So we want to find the first 9 terms. So we want the sum of the first 9 terms. Our first term is 2. 1 minus our ratio. So to get from here to here, we had to multiply by -3. So I'm going to put that in parentheses here. To the 9th. Oops. No. To the 9th. And then over 1 minus r, which is -3. Now, my advice, I put a scientific calculator up on Google Classroom, my advice is to use that, type this in, use all your parentheses, and you should be golden. So you should get 9,842. Again, use the scientific calculator I put on there. You can actually type this in as is. Make sure you use parentheses, and it should be good. All right. Next one, same formula, so you're still finding the sum. S of n equals a sub 1 minus r to the n over 1 minus r. Same formula, same summation formula. The issue is they didn't give us a sub 1 here. We have to find it. So my first term, I plug in 1, 2, 3 to the 1. So 2 times 3 is 6. There's my first term. So we get 6, 1 minus r to the n. So your ratio is what's changing. So here my ratio is 3. If you don't see that, or if you forget, you could always find the second term. Right? 2, 3 squared. So we have 9 times 2 is 18. And you could find out my first term is 6, my second, how did I get from 6 to 18? I multiplied by 3. But it will be whatever's changing in your function. N, we want 8 terms. And we're going to do 1 minus 3. Again, you can type this into the calculator as is. It'll do it all for you. Order of operations included. And you should get 19680. All right, moving on. A job that pays a salary of $30,000 for the first year. During the next 29 years, the salary increases 6% each year. What is the total lifetime salary over the 30-year period? All right, so we're going to have our formula S of n equals a sub 1 minus r to the n over 1 minus r. All right, so our first beginning salary was $30,000. We're going to have 1 minus my rate. Now understand, if you're increasing by 6%, you actually multiply this by 1.06. So my rate is going to be 1.06. Over 30 years, there's my n, and 1 minus 1.06. Again, use that calculator, use your parentheses, type it all in, make sure the parentheses are right, and you should get a very nice lifetime salary over that 30-year period. Seems like a lot, but that's over 30 years. All right, next one. This is a formula for interest compounded however many times a year. So n is actually the number of times you're compounding in a year. So let's start. All right, so we got P. P is your deposit made each compounding period. So here they're telling us they're doing $100 each compounding period. You got to be really careful with parentheses here. 1 plus rate, again as a decimal, not as a percentage. So 9.5%, we're going to move it once, twice. Would be 0.095 as a decimal. So 0.095 over n is your number of times compounded in a year. So if you're compounded monthly, that means you're going to compound 12 times a year. To the n times time. So they started at age 30 and want to retire at 65. That's 35 years. And then minus 1 and close that. All of that is over, and we got another fraction down here, r, which we already know is 0.095. Again, always change it back to a decimal. We don't want a percentage. And number of times compounded in a year is 12. If I have time at the end, I'll show you how to type it in, but you should be able to type it in, all parentheses, all that good stuff, and you should get 333,946. So that's how much you will have when you retire in your IRA. Then it says find the interest. So you've got to find out how much you're putting in versus how much you're getting out. So we're putting in $100 every month, and there's 12 months in a year. Oops, times 12. And for 35 years. So at the end of that 35 years, I've contributed $42,000. But I've gotten out $333,000. So let's go ahead and subtract those. 333,946 minus my contributions of $42,000, and I got $291,946 in interest. That is a lot of interest. All right, I'm actually going to keep going. Find the sum. Here's your formula. And I'm going through pretty fast because I want to get through this in one video. A sub 1 is 3 over 1 minus your rate, which this one's not as obvious, so I would use the division. 2 divided by 3 is 2/3. That's my rate. 2 times 2/3 is 4/3, times 2/3 is 8/9. So your rate is actually 2/3, and you type this into a calculator, and you wind up getting 9. You could also do the keep, change, flip. 3 divided by 1/3 minus 2/3, so that's 1/3. Keep, change, flip, and you'll still get 9. Last two. So 9 repeating as a decimal is actually 9 over 10 plus 9 over 100 plus 9 over 1,000. So this actually is an infinite series. So we can use, or sorry, infinite sequence. So we can actually use that formula. The sum is a sub 1 over 1 minus r. All right. And we're going to go ahead and say a sub 1 is 9/10 over 1 minus r, which my rate every time I'm multiplying by 1/10. And here you have 9/10 divided by 9/10, right? 10/10 minus 1/10. Keep, change, flip, you get 1. Keep, change, flip, you get 1. And the last one, so we're starting at 2,000. Each consumer has 2,000. And they assume that each person will spend 70% of this. So 70% multiplied by 0.7, you get 1,400. And then they're going to spend 70% of that, which is where the 980 comes from. And then they're going to spend 70% of that, and it's 686. And it keeps going. So we're going to use the same formula. A sub 1 is 1,400. And then 1 minus your rate, which again, our rate is 0.7. Right? That's what we multiplied by, 0.7, 0.7. And when you type it in a calculator, you should get 4,667. So determine the total amount spent on consumer goods from the initial 2,000. They gave you a $2,000 rebate, and they are expecting that you're going to spend $4,000, $4,667. All right. That's it for today, guys. Get the homework done.